And the topic of this afternoon's presentation is Assured Identity, Commercial Innovation to the Tactical Edge. Assured Innovation to the Tactical Edge. That sounds a lot like as a service model, doesn't it? There'll probably be a little bit tied to that. Your speaker today is Major Nick Ziegler. He's a military director out of the Innovation Office at DISA. I want to tell you a little bit about him. He's a little bit unusual. His mother was an Army security agent with especially a Morse code. His father was a signal officer. Go figure. He grew up in this area. He went to intermediate level school at Air Command and Staff College at Maxwell Air Force Base. He followed that by moving to 7th Special Forces Group, Elgin Air Force Base. He's deployed. He came back and he was an aide-de-camp for General Lynn, previous CG here at DISA, which is noteworthy in itself. He's currently serving as the Chief Innovations Officer at DISA and the lead innovator for the agency's Assured Identity and Multifactor Authentication Initiative. This is a big deal. It's a big issue. Understanding and making sure that we have positive identity at all levels is critical, and he's going to talk to you a little bit about that this afternoon. Let me introduce Major Ziegler.
Thank you very much. Appreciate it. So as any good signal officer, I tried to get here early and make sure everything was fixed and perfect, and I've failed again. So we'll have a little bit of technical difficulties with some of our actual demos, but I'll burn through the slides so we can kind of have a discussion event with this. As stated earlier, the Emerging Technology Director is a new directorate at DISA. It's only about 6 months old, but it stemmed from a demand to go into an environment that's different than where we are right now. It's an environment in which we're looking at technology as it comes to the forefront in order to get down to the tactical edge, and that's really what this speech and this presentation will be about. What you see here is kind of our mission statement. My boss, Steve Wallace, is back there in a nice pink shirt, smiling at everybody. Is it Mod or Salmon? Salmon. When you become an SES, apparently you have to wear very nice colored shirts. I don't have that problem. So as you kind of see where we live, we're in the DBC, so if everybody knows anything about DISA, you've got your build side, which is your DBC, and then your ops side. And so we live inside that build side, but we really live across the entire agency from every directorate, every center, and we are here to not only find out ways to enhance our current situation inside the agency, but also enhance our partners from the services, other agencies across the DoD. Some of these key icons you'll see here, mobile hardening, we'll talk about each and every one of these, DevSecOps, CBII, mobile desktop convergence, and really what I want you guys to take away from this whole brief is we are looking at how do we go into a complete mobile platform environment. How do I take what we have for technology, which everybody who has a kid, I think Mr. Monterano says every time he gives his speech that his grandson takes his iPhone and breaks it down. So using that as kind of your complex understanding of what we're doing, we're looking at how do we get to a mobile platform where it could be whether it's a BYOD, a bring your own device, or a GFE, which is a government furnished piece of equipment that has multi-class. So right now, if you're inside the DoD, you typically have your personal cell phone. I think there's still pagers, which is unreal, but there are still pages. You got a DMUC, which is your Defense Mobile Unclassed Cell. You got DMCC, which is your classified cell. You got a Wi-Fi kit, a tablet, and some type of laptop or desktop for both unclassed and classed. And if you're a TS user, you've got a TS. So you literally have a go-go gadget badge of like kit on you. You're a walking Radio Shack, as we kind of call it. I know Radio Shack is gone, but I still remember them. So next slide. Again, just our mission. We'll reiterate this throughout, but the big thing is to be agile, flat, and fast. A lot of the things that we do inside of acquisitions at the agency is very cumbersome. It's very bureaucratic. There's a lot of slow stuff inside of our acquisition process, as well as identifying technology and bringing it forward. So everything we do is about 18 months from acquisitions to user trial to decision, whether it's going to be an enterprise solution or not. So everything I'll talk about is somewhere along that 18, maybe 24-month process. Next slide. As stated earlier, here's our 3 innovation divisions. We broke it down based off of how the agency is laid out. And so essentially you'll have your innovation support, which does a lot of this right here, where Rick I. Barber is actually the division chief. So if you see Rick I. running around, he's there to work on things like disruptive, bringing things from inside the agency up, working at conferences like this to set up and be the outreach educational portion of it, and that type of stuff in there. We also then have Carlton Harris, who runs our cyber innovations environment, and then Charlie Fields. This is our pillars of action. Really the big thing here is again, succeed or fail fast. Everything I'll talk about today, and I know it's kind of the buzzword bingo, but everything we talk about in here is not a unicorn. It is something that we are really chasing, we have a contract on, and that we're looking to bring to the tactical edge as soon as possible. Next slide. Actually, go back. Did you guys get the CD yet? All right, we'll go. Next slide. So our technology roadmap, this is approved by PAO. It's out, so everybody can kind of see this. This is how we are looking at attacking not only the problems, but finding new solutions. It's a build from bottom up, and as you can see down there, actively engaged, actively pursuing, monitoring, and enabling activities. It's truly what it means. We're looking at utilizing our ability to take on, whether it's an OTA, other transaction authority, a CSO, a commercial solutions offering, or some other type of rapid acquisitions process in order to use those to enable technology. And how we do that is based around everything you're going to see today from our Assured Identity program. Assured Identity is not just the typical standard of I have something, I know something, my common access card, my PIV, whatever it is. There's a lot more to the program than just understanding about identity, because there's a lot more about your identity than most common users understand. So as you see up there, the strategy, policy, and outreach, really the important part there is that's where we live. If everybody knows from DISA, you got Admiral Norton. She's got one hat, which is Cybercom, that she reports up to Cybercom on. The other one is straight to Mr. DZ, the DoD CIO. And so we have a great opportunity inside of both of those houses in order to affect cyber strategy and also in order to enable and enhance some of the DoD CIO's information requirements. So you look at that, leveraging browser isolation, enterprise identity provider, next-gen host security. You can just read the list, but as it builds up, these are actually capabilities that we're somewhere in the contracting process with or looking to enable inside of there. Next slide. And please ask questions. If anybody has questions, I'd rather ask questions on the slide versus waiting. So jump up, there's a microphone, tell me I'm not doing the right thing, and we'll keep going. But this is really where it started at. Two-factor identification. So right now we currently have a point in place and something that you have, right? A point in time identity. So I have a common access card, I walk around with it, it's got keys on it. I leverage those keys with a PIN and it allows me to access into any of the DoD environment. And it basically gives me, based off of the access control list, it gives me the keys to the kingdom, right? So it allows me to just log in and I'm validated, I can run around the world and do whatever I want. And so it never gets revalidated unless you get kicked out for some reason. So it seems kind of, cumbersome at its point, but it's been that way for about 12 years now. So as you see, we're using identities. There's still username and passwords out there. People are doing shared credentialing. People are utilizing somebody else's credentials in order to do something because of the fact that we still have those components enabled. But what the ecosystem allows us to do is understand that there is, multiple devices that are leveraging in. A good story I always like to talk about it was my last deployment. I had a 2-star general that had 11 different houses across the world, and he'd log in, get on his nipper box or his sipper machine, and then he'd leave, go to the next country and log in. And at one point we had 11 different countries lit up where he had something on that machine. And so it didn't validate, it didn't kick him out, but he still had his user profile active somewhere else in the world. So that's a common ecosystem. Transport requirements, so we'll talk about how we're looking at the future and how each one of these different things from 5G, unlicensed spectrum, all the different capabilities you guys hear out there, how we're looking to leverage them inside the agency. Next slide. So this is, as I was stated earlier, I was General Lynn's aide, and so this is a slide that I carried around the world with me. This was his slide, but it really is, it's the culmination of his 39 years in the military and kind of where we built this enterprise solution from. As you see, you can talk about identification from medical to credit cards to ATMs to financials to you name it, Bitcoin, all the different things that you hear coming around. Some of our cyber incidents in which they were all identity-based environments where OPM has sent out enough of those letters to people that your identity was stolen. And then you take it from that down to the tactical edge where you've got multiple users with multiple pieces of kit trying to get access to data. And so this is really where it started. We started looking at how do we build a world in which the agency, the DoD, is not building one-offs. We're building an environment that leverages commercial solutions in order to enable the security parameters that we require. Next slide. So this is where we want to go. A seamless, frictionless environment. And that's truly what it is, the ability to be in your boardroom or on a battlefield with the same kit that you constantly do. So the requirement that I kind of taken on is how do we get to there? How do we take commercial technology and basically build an evolution of it inside of our environment that translates to the commercial environment as well? Because as far as we know, the way things work in the commercial environment is what sells is what people buy. And what people buy is what we end up getting back through some other means. So our ability to influence that and understand how it's influenced is what we're looking at. But continuous multi-factor auth is what we'll talk about here for a little bit. And then how do we get to that one mobile environment? So next slide. So this is our focal point. It's all over the place. I'm dancing over here at the slides. About 2 years ago, we went into the first other transaction authority agreement with Qualcomm. We did about 18 months of research, looked at how things were coming, looked at what was going on in chipset manufacturing. A lot of people don't understand this domain. It's a very complex 18-month cycle where it goes from hardware build to software adaptation to inclusion into an OEM's flagship device. And so what we were looking at from OEM providers and chipset manufacturers was how do we get this on hardware? How do we get it into an environment that is not solely based upon the ability to worry about slides moving back and forth? But so essentially, we went and looked at chipset manufacturers and understood that how do we get into an Android platform and how do we get the capability and functionality to work to where the next chipset came out, it was readily available in the commercial cycle. So we've actually, right now, we're in a user trial in which we built this functionality into it. And I have demo devices. We can show demos here at the end. But how we looked at it originally was contextual factors and biometric factors. So biometric factors would be your hard factors, your fingerprint, your facial recognition, iris, your voice, those types of things. Those are considered hard biometrics. And your contextual factors are things that the device knows about you and where you're at, whether you're connected to a Bluetooth device, whether you're connected to a certain Wi-Fi, whether you're connected, to different peripherals around you, a monitor, screen. All of those things can be adapted into contextual factors about you. So the first two things we looked at was hardware attestation. And just for layman's terms, what hardware attestation is taking the hardware and generating a key. And so that key is similar to the keys that we have on our common access cards. And what we do with those keys is we put them into our certificate authorities, and we leverage them for auth. So the device generates the key, and then we use these contextual and hard biometric factors about you in order to auth who you are continuously and verify after you've entered the network who you are, where you are at that point in time. So interesting enough, General Lynn, I always like to tell this story. So we came up. He said that there was like 240 factors, and I was like, that's crazy. I'll never see 240 biometric factors about you. I think we're at like 46 total that we've found to be involved in this. But the one that I never really wanted was gait, which gait isn't like, your fence walking into your backyard. Gait is literally how you walk, the way your body moves, the things about you that wherever the device is on yourself, that it can be leveraged and that everybody has their own gait. So one of the first things I put into the contract, because I thought we'd never get it done, was gait. So I wanted to see how gait was done. And probably the most interesting research that we've done is being able to validate that each user's gait is completely different and that you can use it as a hard biometric on you. So next slide. So how are we doing this? Essentially what we're doing is we're burning into that hardware a key, building a root of trust between that hardware and the attestation statement, and then being able to use that inside of our certificate authority. So we still have CAs and RAs that are in there. If everybody is known, at any point, I always like to point out Brandon Iskey in the back there. He's our purebred lead. So he is really the guy that's been leading the way on how we do derived credentials, which right now is I take your CAC, I take the keys on there, and I derive another set of keys that are then stored inside the device. And then that device allows you to auth into it. You don't have to put your CAC in. I know a lot of people, I had like 200 of these CAC sleds for the BlackBerries back in like OIF 11, where you walk around, they sent you all these things, and you put one on the back, and it's like literally the size of an FM radio, and it never worked. It always died. So that's really was, to me, when I found out that we were going inside of a derived credential environment, very interesting, because that's where we should be living. We should be living inside of a world that there are more complex systems out there that can do the same thing that one token does. So how we leverage that purebred keychain is a lot of the stuff that we've been working in. Again, the security Bluetooth connection up there, one of the parameters that we had is we need to fill a lot of gaps in Emerging Technologies Directorate. And how we fill those gaps is we look at how is the cultural understanding of where we are at that point in time going to evolve over the enterprise solution that we're offering. So we didn't look initially at getting rid of the laptop or desktop environment. We looked at doing device as a token. So think I just created these certs or keys on the device. Now I want to use those same keys to replace the common access card to access a desktop or a laptop. And so what we were able to do is prove out that I can then use a low-power Bluetooth connection, generate a token on device, and then use that device to auth into a laptop. So right now, the way it works is your regular DMUC, your unclassed phone, you can walk up to the proximity of that low-power Bluetooth emissions, and once it connects to that provisioned laptop, it triggers the laptop, it sends the keys over, and then pressing the space bar allows you to auth into that laptop. And then once you move away from that device, it automatically disconnects and now locks the device. So a lot of the issues we've been having over the years has been how many people put their token or CAC into their computer, leave it in there, and then they walk away from it, and now whoever comes in behind them has that seat. So that's the transition of what we're talking about here. Next slide. So this is what we did. We looked at an ARMS-based set for chipsets. So if anybody knows anything about mobile devices, the way they work is you've got basically your trusted execution environment and your rich execution environment. Think of rich execution of all the software that's loaded on top of the hardware. That TEE side is all the hardware where we can build that root of trust and actually store those keys. So the keys are generated inside the TEE. They're stored in there, and they're stored inside of what we call the key store. And then once you use that CMFA functionality, you open up that key store and it allows you to leverage those keys. As you can see, right now you have Bluetooth, gate, you've got your peripherals, you've got your facial recognition, and you've got your voice outside in that RE. The reason that is because that's where your sensors live. Think on your phone, your camera, your microphones, all those things live inside that RE because that's where they're built. And so you collect them, and what we're doing is we're collecting a multitude of hard biometrics and contextual factors so that if somebody was to spoof one of those, if somebody was to break in and do a man in the middle, we know there's other capabilities that we can value. So it allows you to value and devalue the different hard biometrics and contextual factors as they come along. And then it's fused using a fusion algorithm that we actually have inside of the RE. It brings you out with a trust score, and then that trust score based off of the percentage or the high, low, or medium, it allows you to actually validate what auth they have. So what I want you to think about now is I have one biometric factor, and this is simplistic on how we do it. I have my face. I looked at my device, I pulled it up, and it validates my face. That would give me a low trust score for a low point in time. I need contextual factors in order to have a decay rate. And what that decay rate does is it allows more time at that level of that trust score. So now I've got my face, I've got my fingerprint, I'm at a medium, and then now I have a Bluetooth connection, I've connected into the Wi-Fi, so my decay rate's going higher, my trust score's going higher, and it allows me to use those keys for a lot longer period of time. And so what we're looking at there is if you use the device as a token, and I'm at my desk, and I'm not walking around, I'm not changing the environment, I need to be in a trusted environment that allows for me to use those, and I'm not regularly doing this, looking for my face and doing it. So that's really what we were building upon here. Next slide. Do we have the CD? You got it? No, I want to show it right here. Is it ready? So this is where all of that I just said I want to say diarrhea out the mouth at you. This is what we're going to show with the DVD. So this is what I'm talking about. So the trust factors, the biometrics, and the contextual factors are leveraged inside of a videos that we'll show. And the main thing to understand inside of the video that we built is how it changes, how the difference from how many different contextual and biometric factors you have. You'll see the trust score change, and it allows you to auth into a device. So I always like to use that. One of the big things we talk about is your bed-to-bed story. So in the morning I wake up, I look at my device, and it gives me a low score. And what's that low score do? It allows me to auth into my device, and that starts my identity. Then as I'm getting up, walking around, it connects to my Wi-Fi, my home Wi-Fi. It's a trusted network. That trusted network elevates contextual factors about me. So now I'm able to go, all right, I've got this low score, but I've got 15 minutes that this decay rate will slow down unless I add other contextual factors or other hard biometric factors. So now I need to go send an email. Well, in order to log into a DoD email off my mobile platform, I'm going to have a medium trust score. And so that trust score then needs additional contextual and biometric factors about me. So once I get it, I log in. And then while I'm in there, I need to encrypt, decrypt an email, which is going to require a higher level or a higher threshold of that score. So all of those things, that's a good way to understand on just the general basis of what we're looking at. The other thing, all this stuff is policy-based, driven at our mobile device management capability. So it allows for you to validate, change those scores, change what level of auth you have, and how you work inside of the space. So that's what you kind of see there, how it works, how it goes. Most of the stuff that we're doing right now, again, is in science and QRDs, as we call them, reference devices. But we've actually been able to move into a large OEM platform in which this is available right now to the civilian environment just by the work that we've done. Ready? Let's go. All right, so we'll watch the video. You didn't know you were going to come and get a movie. It's a good movie. Maybe. I'm setting the standard big today. It's going big. Any questions while we fill space with the movie? So in the first issue with Qualcomm, the way we said it was based off of how many factors you had. So as you saw, there was 4 contextual factors. So yeah. So we got up to a max based off of just our, again, this was all just talking with NSA and other partners on how they would value it. So some of the stuff is weighted graded based off of known standards, commercial standards, like how long we had for 3 seconds to validate the facial factors. But the contextual factors were all based off of which ones were valued higher because of the trusted functionality of them, and then that would give you a longer period of time by adding more contextual factors. And then again, leaving those environments. So one of the things we're looking at is not only the logical environment, but the physical environment, right? So for access onto Fort Meade, you use your CAT card, you put it up, you get a little swipe, it allows you back on. So one of the things that has been intriguing to us is how do you use your device, NFC tap, onto a camp poster station? Now you're talking about VA benefit, anybody inside the DoD, whether a VA or any other person, a veteran, they now could have that same functionality inside of a commercial device, which allows us to open up some of those apertures for getting on base and whatnot. So that would be another one. So there's 2 realms inside of it. It's not really a commercial solution for classified. It's more of the initial basis of understanding how we can secure a device. Being able to trust, so hardware attestation, by being able to attest to the state of that device when I provisioned it and when I generated that token, the things I know about that device are very similar to how we do CACs now. So really our common access card is batch system. We get them from 3 vendors. We pull those in. Those 3 vendors then have, a chain that goes with them, chain of custody. So all that stuff can actually be done inside of an attestation statement, so that when we provision the device, we also don't have to be there in person. So those are the types of things we're looking at. So if I can have a device that I know everything about the end user at the end of it, then that CSFC environment becomes a lot more available based off of those security parameters. I guess we're not going to watch a video. That's all right. Let's go. It's online. You guys can, I think it's on Vimeo. We'll push it out. Failure. We got more slides. I'll talk. We got water. Any other questions? I'd rather have questions. Next slide. So some of the stuff that we do inside the Android container is called Knox. I think a lot of commercial industries used Knox for business. We have our own environment. And so one of the things that we're doing is we're looking at how do we enable the Knox container to validate through the biometrics and the contextual factors that we have. So right now we're allowed to do customizations to it is what we're looking at. How do we take the OEM devices out there and all the work that we've done with Qualcomm and look to go to a flagship device? So everything you see here is kind of where we're going. We're adding wearables into it. A lot of the DoD is looking at how do wearables, not just your watches on your hand, but maybe rings, necklaces, other things that you have commonly on your body that are always there based off of no matter what you're wearing. How do we integrate those in the next generation? A lot of people will see wedding bands coming out. There's a lot of technology being used into how we can put identity on a wedding band. So you could always have that on, unless you play golf. That's not going to help you out. But integration of those wearables is a very big thing to us because think about, as I talked earlier, that bed-to-bed story where I wake up every morning, the first thing I do is I put my watch on. So now with watches, whether through vein recognition, through being able to attest to a pulse, that there are certain things that this watch does that can validate that a human is alive, that they have something they know about you, and that now that connection to my device gives me that straight up continuous multi-factor auth from the first phase of my day. So that's really what we're looking inside of the customization of Android. I think a lot of people have seen too that this isn't the first time, like MFA is multi-factor auth is not something that we came up with. It's out there. Everybody who has a bank now probably gets a text from their bank saying, is this you on this device? Oh, I validated your phone number is correct. These things are already out there. We're already giving them inside of a commercial domain. So now leveraging them to validate the security posture that you require for these things is what we're looking at. Next slide. So the big thing for us, as I said earlier, was this mobile platform. How do we get away from the 17 items that we have on our regular body, from the mobile devices to desktops, laptops? So everything I just told you at some point needs to converge into an environment that becomes seamless and frictionless, right? So everything that this device has, my mobile device can do everything my laptop can do. It actually knows more about me because of the different, functionalities that it provides, from how you hold the device, where it's at, those types of functionalities that your laptop will never give out is something that you can be leveraging. And again, if I haven't said it, the continuousness is the most important thing here. Continuous validation that you are who you are, as well as continuous validation that the device is in the state that we want it to be in for security. And that in itself is an end user experience that most people look for. I don't want to be putting in my PIN. I don't want to be putting in a pattern. I don't want to be putting in my face every 5 minutes. I want the device to consistently do that and give me that continual validation that I'm in a secure environment. Next slide. Hey, Brian. I was going to try and show a Navy guy in Army uniform, but they failed me again. So the goal here, again, is we looked at 3 different realms here. How do we get to hardware-based chipset manufacturer? That was our first reality we wanted to chase. The second one was, how do we get to an OEM? How do we get inside of an OEM and understand how they build things, how they leverage things, and what their cycle is for their software inclusion? And then the last thing was leveraging small businesses. So we looked at all the different small businesses out there and how we can get additional contextual factors to be leveraged. So what we're looking at here is everything that I've been telling you right now is on device. It's all done here, from the hardware to the software. The device tells you who you are, what you are, and how you're doing it. But we also wanted to check inside of a cloud environment how those contextual factors could be pulled against other people, could be pulled against yourself, and could also be pulled inside of a secure environment. So don't think it's sending up to the cloud and it's validating my walk against somebody else's walk. Everything's still done on the device, but what it's doing is sending it back up to a secure GovCloud environment and validating that the last time it checked in, when you created that actual polling, that it now validates against the historical reference inside of you and validates that there was no change to it. So what we're looking at inside of this environment, though, is not just the auth into your device. If something was to happen, if let's say there was a man in the middle or if somebody was spoofing something on your device, are there other things out there that we could then validate against in the background, seamless to the user, that if something was taken, we could then disallow or not allow them into the environment? So as I was talking about before, how you hold the phone, the way you hold the phone is actually different for everybody. How you strike the phone's apps, how you put pressure on it, how you move across your device, how you text, it's all different for everybody. So by being able to pull that and being able to monitor that and create basically a view of who you are, I can then essentially validate in the background if something changes about you against that baseline. So this is kind of what we're looking at with that. We actually have 3 of those factors right now working inside of an Android device. Next slide.
These devices may one day be on the battlefield.
Yes, that is our intent.
And so on the battlefield, you're not going to have a continuous line or expect a continuous line where you're constantly developing a machine learning module or training module to continue the algorithm if you're in a long fight.
So we're talking disconnected versus connected, right?
That's right. Or at least commanders using emission control, which they're going to have to do against a peer competitor. So how does that play on that?
You just set up this slide. Thank you for that. Sorry, you did. So the disconnected versus the connected environment, I think that's a common tactical discussion point, right? This fight where we're going to be disconnected from a near-peer engagement. But I also want to say that there's that disconnected environment of everything I talked about before is small inside of the agency's perspective, but it's what we look at as the most important, right? So the disconnected, I've just told you everything about disconnected. That everything's going to be on the device, everything's going to be locally stored and validated on the device, and my ability to auth into my C2 environment, which command and control environment, in that real-time perspective is going to be how much I have access. So what you see here is what we're looking at from that perspective. We're looking at, regular device, regular user, 5G enabled, 4G enabled device. Whenever I'm in a CONUS or OCONUS environment that has that fully done, I like to use my experience at 7th Group in South America. Like, we barely used satellite or local fiber. Everything was cellular enabled. Triple cover, canopy, all the things that were going on. So it's interesting to me that the global world is always looking at cellular environment as the #1 priority, but we look at it from a large pipe environment of where we're going to use fiber. So what we also looked at was the ability to harden the mobile device and also provided other functionalities. We call them backpack kits, essentially. So think of some of the vendors out there in the mobile environment where they're slapping other things onto the back of the device, whether it be a battery or some other functionality, to allow for that device to be fully used to its requirement. So could I take a mobile device, slap something on it hardware-wise, and then put a different functionality, whether a cradle port, so think multiple SIMs. Could I make it an FM radio? Could I make it a satellite connection and then at least have some type of ePLARS environment where I'm hopping from soldier to soldier back to a connected tactical or non-connected tactical? So everything that we're talking about from this perspective everybody thinks ecosystem CONUS, but we're really looking at not just the ecosystem in CONUS, how do we enable to the tactical edge? And there's a slide that I'll show you each one of those points that kind of how we do it from what's out there both commercially available and what's out there both tactically available. I think we look at it in a real-time war fight that we'll find a way to fight locally across the local networks and then bring our networks up in order to fight that tactical fight. And then if we all go dark at that point, the interconnection from point-to-point mobile device, so like think mobile mesh, the ability for me to have platoon level comms all the way back to the CP will be dependent upon the proximity of my forces, and that would just be kind of how we work. And so that's what we're looking at with this. But we're also looking at the devices being hardened from a perspective. So think, how do I also block the sensors that I don't want to be used against me in that combat fight? Or if everybody knows, most of the places inside of a secure environment, you can't bring your mobile device. So if I just put my identity on this, how am I going to leverage that in order to auth into the DoD net? Well, we look at it from the perspective is if I can block both physically and logically all the sensors and the collection accesses from this device, then I can potentially bring that into a mobile a SCIF or inside of a secure environment like the Pentagon and not worry about it because everything's kept on device and anything that could happen from external to the device is blocked. So you add those two things together and lightweight, small aperture. Now, 82nd Airborne Nick jumping out of a plane with 6 radios in his rucksack, I can go down to this one device. And I can also go down to one device that for $1,000, if I break it, instead of having a $30,000 radio, I can get rid of that. And so it looks more through the cost avoidance environment and how do we enable the things that are already available. Does that kind of help out? Did I dance around enough? Or no, I'm just kidding. Next slide. So the other thing we're looking at too, and this is again more connected, is how do we look at virtual mobile environments and virtual desktop environments from this? Everybody who has a device right now, whether it's an Android or iOS, probably has an HDMI plug-in that plugs into their home monitor so they can actually work or connect on it. So this is what we're looking at from a perspective is how do I enhance a device through an application that lives on some type of ecosystem. We call our ecosystems like data centers or on-prem. So one of the biggest concerns I always get when we start talking about identity is all right, well, if you're going to put BYOD on my phone, now if the government wants to subpoena my device, they can just take my device. And all the other stuff I have on there is now governmentally owned. And then the other thing, too, is privacy. Well, if you're going to give me BYOD, then everything I do on that device, then all the stuff about my identity is leaving the device. And so I've already stated that we're not leaving the device. Everything's on device. But how do we get to a BYOD environment without the concern of what's on device? Well, we do that through a virtual environment. And so we're looking at 2 different environments, one being the virtual mobile instance in which when I log into an application on my device, it looks and feels just like that same base native environment that I was in. And then when I plug into the HDMI port in my desk or office, it enables that environment into that desktop enhancement. And what we do with that is we now tie it back with some data services that make all of the different shared connections relevant. So whether I'm logging into a VDI or a VMI or whether I'm on my native device, utilizing some, if you guys haven't heard of it, MilDrive, which is our data storage capability, everything goes to the same map data place that I have, and that's where we're working towards. Questions? Next slide. So this is your answer. How do we live inside of this environment? And this is where we're going. So if everybody sees right there, this is all the communications that we have inside the DoD, whether from SATCOM, MILSAT, WSG, AISR, all the different functionalities that we have from COTS availability to GOTS, government availability. Here's what we have. And so the reason you can, again, I'm Army guy, you can interchange the 2 dudes taking a knee on the radio with a sailor and an airman or whatever. This is standard across the board availability. So now make the perspective on this that we're going to fight in every network that we can fight. And by utilizing them and creating a dynamic mesh, do you hope that at the point that we become disconnected, that this is what we've used everywhere? So we talk about SATCOM being down. We've got MEO contracts. We've got LEO. We've got Iridium. We've got Thorium. We've got all these different GEO and low order and middle orbit contacts, and then we have both our FM, HF, and other backbones. So the initial requirement is to fight on our commercial networks and then move into our tactical networks. So you give me that look. I like it. Go ahead. I love the disconnected argument.
So where are we going with the fact that exponential data growth is, so what you're doing is you're telling us the physics isn't going to be there to fight with that stuff in the future, because the physics can't transport that. It's not going to move the data around that needs to be moved. It's going to be growing exponentially in an
Are
automated...
you talking like ISR data, or you're talking like, what type of data? Me pushing a PowerPoint?
Let's just take a broadband antenna.
Okay.
Basic broadband antenna that you've got to do to compete with either a peer competition between China and Russia. That's 10 gigabytes a millisecond. You're going to have, at the division level, you're going to have at least 30 to 40 out there. That's just one battlefield application system. And you expect to have those systems across what? There's 15 BFAs, each having thousands of systems, moving data like that. So while it makes sense up until you get to the growth of data that's going to happen on the battlefield, the question is how do you continue to make that happen and continue to make sure that you're authenticating and making sure the right guy's in the loop? Because now the automation is not just humans in the loop, but humans on the loop with automation.
So appreciate the question. So here's where I'll go with that on you. So first, everything's on device. I've got a terabyte of data on this device stored, right? So part of our TTPs is going to be push everything to the device because I trust the device and I trust the end user, right? So if that disconnected environment comes to a terabyte of data is ridiculous. Expandable data. If I need map data, I bet you I could put map data on this, which is most of what we have from an uplink environment. So that's the first thing. Second thing is the ability to use the device to bring in all that data and correlate it to the operational environment is all on device now too. So if I'm fully disconnected, I have that. I don't have that right now. So you're talking about a BCT that has a 10 meg segment over a KU band that's used up for all of its tactical on, drash tent environment. So what I'm looking at is the tactical edge being away from that. How do I get all that out? So when I send a soldier on a mission or I send an operator on a mission, they have everything they need, whether it's connected or not connected. I think the near-peer environment as well is very concerning, but everybody talks about us being disconnected against our peers. What are our peers going to be at that point? Do we assume that they're disconnected or do we assume that they're not? And so my point is if they aren't disconnected and we have the ability to penetrate their networks with whatever's local on that tactician, are they getting real-time data to that source and be able to make the most accurate decision they can on the enemy? I would say yes. So being able to do everything we just did right there is something we don't already do. We don't already use every one of these. We use single pipes, single sources from whether it's a JNN to a hub node to a CPN. It's an all-tactical environment that's readily available with tactical satellite. And then we bring in commercial solutions to live on, right? But we're not giving it through an FM perspective. You're still talking about, frequency requirements and all these other capabilities that if you're utilizing FM or HF, I owned an HF kit in Eglin that I could talk to Germany, I could talk to Japan from that. 1024, but I'm still talking over, high frequency environment. So could I, on this device, use all those capabilities as well? Yes. Are we right now? No. But in the future, if I had everything on this device, would it be a better environment where I'm making C2 decisions on the enemy in a real-time, fight? And so that, to me, yes, we don't have it now, meaning at the tactical level, but that's what we're here for. We're here to explore it, and also, as I said earlier, outreach and education to say, hey, you're spending a lot of money in this environment, but I can do it all right here. And how do I get that money that we are doing? By going to a mobile device and moving away from all this hardened infrastructure that's required. So, good question. I appreciate it. I love the disconnected environment that everybody talks about, just like the insider threat. They're very real threats to us, but we also have to fight against it, not fight from it. And so that's what we're looking at, is how do we fight both of those worlds by identity-based. If you do something as an insider threat and I can validate that the identity of you was on it, can I not cut you off the network? Your identity now has to be spoofed. If your facial recognition, if all the body biometrics about you are implemented into a system in which the device validates who you are, if you do something nefarious on that network, can I not block you from that network? So just think about it from that perspective. We're not looking at it from current value standard right now. We're looking at it from a futuristic standpoint of how do we secure the one thing that we think is most important right now, the mobile environment, and how do we make sure that your security, that the global security on that device is also there as well. So, next slide. So this is one of the first ones we talked about. So I have other slides, but I wanted to kind of get to this one before my time's up, and essentially just talk about some of the things we've done. So we initially looked at as that you talk about that use case and where username and password credential sharing has gone down. So we actually went into a small contract with a biometric capability on your laptop. So think keystroke, dwell time, and movement, mouse movements, that we could actually validate that everybody types differently. You know, how many people in 9th grade did 85 words a minute, and maybe still can do it, I can't. But that actually is a biometric factor that you consistently have. How you move your mouse, how you roll on the mouse, those are things that you can be collected on to validate your identity behind it. So we are able to test this out, understand what it was, and see some of the functionality of this capability. We then passed it on to an Army environment, NetCom. They tested it out, validated what they thought about it, and so we all kind of determined that it was immature at the time. And what we were able to do from a taxpayer perspective was save the government money by allowing one of our companies to take on all that research that we did to say, hey, at this point in time, it's not something we want to do. So looking at something from a failing perspective doesn't always mean that we didn't find a way to be successful in this domain. Next slide. So with the video and all that, we would have had an awesome experience. So I apologize. I have Navy guys helping me out, so it just... I had to. So I think we got questions. I know we got some good ones. I appreciate, but any questions, any thoughts, any issues, concerns, cries of inquiry? I wish I had like a microphone.
Yeah. How does some of this work in a contested environment? For example, you talked about short-range Bluetooth. Can that be jammed by a higher power transmitter to prevent that? Also, how well does some of the biometrics work, say, in an environment that has scintillations that are introduced? I mean, have you looked into any of that?
So as you saw, most of the stuff we were looking at was not just a single biometric. So you can assume at any point, if I've got 40 contextual factors and 40 biometrics about me, that if I'm jamming specific ones, or let's say one of the things we learned about with facial recognition, that background light actually changes some of that. So a lot of the companies out there right now are looking at 4K resolution to where the more cameras, we've got 5 cameras on the back of some of these devices now, 3 cameras, infrared cameras, so the sensors are becoming more enhanced, and that enhanced environment is really what's allowing us to value those sensors and the collection that they've done better. The contested environment goes back to kind of his question. I would assume if you understand anything about like how we fight inside of a tactical environment, whether it's from a ranger bat running on the ground to a tank company running inside of this environment, the connectivity, not only from a point-to-point, like I can have a point-to-point connection over here to FM, HF, all those different things, allows us to create basically a tactical mesh. So leveraging current technology to enhance that tactical mesh allows us in that disconnected environment to use whatever space is available. So when we're talking about RF jamming, you're talking about a certain footprint that I can RF jam. And so if I'm inside that footprint, the ability to store everything locally, to have as much data forward as I can, whether through a tank that has some type of data storage array inside of it, or the end user having as much data on that mobile device, allows you to make those decisions until you come out of that contested environment.
Okay, more. Okay.
More.
Okay.
I'm listening.
Okay. Are you able to program a single device for multiple users with different levels of access?
Yes. Okay. So the dual user, yeah. So this one's fun for me as an aide where I owned everything about a 3-star general. And so at the time, yes. So lots of environments that came with that. So dual persona is what we call that. So remember, it doesn't matter about how many personas you have on the device. It just matters that those device sensors can collect, that an identity can be provisioned and built upon that device from you, and then it can be leveraged to validate the difference. So if I'm inside of a device and I'm, say, at a high trust score, and because it's got my thumbprint, it's got my face, and it's got, say, my voice recognition. The minute you took the device, it would kick you out. But the minute that you were out of that device, if there was a dual persona built inside that device, you could then rebuild your identity back into it. Does that make sense? So it's not just, oh my God, I just got kicked out of my device. So one of the things we're looking at is for medical personnel, right? So medical personnel typically walk up to a patient and they grab some type of sheet that's on the patient, medical records or whatever. Well, if we were going to move this to an iPad environment or a laptop environment, how would that doctor be allowed to get in and understand everything about that patient? So a lot of the VA hospital people want to be able to have that dual persona environment where your identity, whether it was in some type of cloud-based validation or on device, could be used for, kiosk sharing of tablets, essentially. Does that make sense?
Yeah. For biometrics, what is the statistical requirement that you can say that people have individual signatures? I mean, there's got to be some sort of p-value for something like that. In other words, gait. I mean, what is the set on which the determination that individual gaits are distinguishable made?
Didn't expect that coming. It's always there. I am not an engineer, no, I'm just kidding. So essentially, everybody looks at that, right? Like, what is the p-value? How do I validate that just because I weight and graded as the premier sensor? I think one of the big things is as sensors evolve, some of the different research that we've done has been able to take let's say a facial recognition, and our current sensors just see some of the ridges and some of the color degradation of your face. But there's actually, with some of the 4K resolution now, I can take a picture of you, and then I can compare it to somebody else and tell you where those different deviations come from and give you that percentage of the change in those variations. And so it's not really what we value right now, it's how we value the technologies that comes to the forefront. By demanding that we have better sensors inside of our mobile devices because of the willingness for the commercial environment to invest in that, because of the demand from the civilian environment where they're taking on hey, I want my mobile device to know everything about me, so when I go into my bank account and I want to send $10,000 to somebody, I want my device to make sure that everything about me, because it's stored there now. How many of us have our bank accounts connected to our cell phones and don't even have a username or password, and if you had too many beers at the bar, left your phone in the seat, somebody can send money on your behalf? Like, that's a common thing. So the demand is really what we're working on. Is how do I utilize the OEMs, how do I utilize the chipset manufacturers in order to understand that the ease of use with this functionality allows the common user to want security in their mobile device. And so that's really what's driving it. Does that help out a little bit? I think I covered everything else we talked about.
So as you're moving to BYOD, it's not hard to imagine a use case where I might be a reservist and I am a government civilian. I'm a contractor, I'm a reservist. So I might have two legitimate use cases, one person. How are you dealing with that when it comes to the biometrics to know which access to give the person?
Key-based, right? It's all key-based. So just because you're a reservist and a civilian and a contractor, it's all based off of the keys that we would generate. Those keys would give you access through our certificate authority. So your identity would say, hey, at this time I'm a reservist, I'm on drill, I have my BYOD, I log into my BYOD environment, which would be some type of virtual mobile or virtual desktop infrastructure type stuff, and you would have to use those keys to log into that environment. One of the things we look at is the reservist National Guard environment is one of my most critical points of presence when we talk about this. If most people know, like the Army specifically, I don't know, your Air Force, Army, retired Navy. So at least for us, our majority of our infantry is in the reserves. So we've got over 500,000 users, almost 1 million users that are in the reserves, compared to our common force is 400 to about 500,000. So when we talk about how we build things, the first people we build to is the Reserve National Guard, and then to the VA, because you build to that lower level, right? So as we talked about dual persona, that's how it would work. You would have a BYOD device that you would generate different credentials. If you have an Android device right now and you have a personal container and a private container, those are different credentials that you use to get into that. So based off of whatever access you have, that ACL, their access control list, would leverage those credentials for access or all. Does that make sense? Any more? Let's do one more. News guys.
Hey, Barry Rosenberg with BreakingDefense.com. So you mentioned a nefarious user at the end of your presentation. And so it's good to know who's on your network, but maybe better to know what they're doing once they're there. Is that maybe the second half of what you're working on, or can you talk a little bit about that?
Yeah, so you hit it. Like, at the end of the day, the one of the premise of us looking at identity-based network access is that don't think just human, don't think just, think about MPE. Think about the identity of all the iron that's on the network. Most of the stuff right now, we're willing to just get on our device and send something across the network and go, oh, we're good, it's willy-nilly, it's AT&T owned. It's not AT&T owned. They own the gateway, and then it traverses whatever else is out there. And I'm not just saying AT&T, I'm saying most of our network goes across some type of fiber that's owned by somebody else. So one of the big things we look at from a trust-based networking environment, we're calling it ZTA, Zero Trust Architecture. And so not just looking at the person as the identity, understanding what's on the iron, what's on the network. So I should be able to tell that when I send you a message from my device that everything on that is a trusted environment. And if not, then I don't make it to you. And that's really where it's looking at from our perspective, is how do we incorporate everything that we've learned about our biometrics and understand that every device, every piece of equipment has an identity as well.
One real last question, if I could. You've answered and you've created lots of questions with this great presentation this afternoon. What do you need from this population, this industry that's here, that would help you get to the next step or next level? And if you can you talk about who you're working with just briefly?
PAO is looking at me funny. So it's the first part. I think the big thing is what I talked about. That there's two parts of that. The Privacy Act. It's for everybody to understand that when we talk about privacy, our kids are willing to do a lot more than we are, right? Think about Facebook, Twitter. I barely had a typewriter when I was a kid, but my kids have iPads. Our kids, our younger generation is moving through a world where their identity is less concerned to them. It's being out there and using everything in that experience environment, having that end user experience. So just as we talk about what's going on with identity, understand that don't use your own perspective, your own look in the mirror. Look at who's coming up behind us and their willingness to do things and their demand to have technology in their hand right now, right here, and not wait for it. So from that perspective, just understand that it's not you sitting here, it's the generations behind us that we're building for. I think one of my favorite comments from General Lim when he left was that same thing. I can't bring technologists and young engineers from college into DISA and give them a laptop that's got 250 gig of storage and 3 gigs of RAM. Like, you just can't do that anymore. No one wants that. So you have to build to an environment where you're bringing technology in. And I'll tell you that, at least from my perspective, I'm a signal officer, but most of my generation as well, from tacticians, special forces officers, pilots, they're just as hip into this environment as any of us are. They want that and demand that technology because they know what it gives them on the battlefield. As for the companies we're working for, it's all out there. Like, everything that I have from a contract, you can go to FezBiz Ops and you can see what the contract is, what's on there. So, not to put names out, if you want to know, every slide there has something in FezBiz Ops. So I think that's a good answer.
Okay, I'll try and wrap it up right here. Major Ziegler, this is a fantastic presentation. Those of you who have been here the last hour have learned a lot from a number of people here asking questions as well. Thank you very much for what you're doing. And I think your slides are going to be online. So if you didn't get the slides, they'll be online. Right. Okay, cool. Be sure to get your badge scanned. But before you go, at 2:45, we've got General Nakasone and Mr. Deasy, CIO, the DoD CIO, that for a fireside chat. I don't think you want to miss that. So get scanned, get on over there, enjoy your week, and thank you for being out here with us this afternoon. Quarter to 4. That's right. Yeah, that was a quarter to 4. Quarter to 4. I'm sorry about that time change.
I don't know if you remember me, Russ Smith.
Yeah, Russ, how you doing, man? How are you doing? Let's stand over.